Hello everyone, welcome back to the 3D Mechanical Design channel. In today's video, we're working through CSWP Assembly Practice, Level 17, Task 17.3. You can download all the required models using the link in the description below. If you find this tutorial useful, don't forget to hit the like button and support the channel. It really helps more than you think. Alright, let's jump in. In this task, your goal is to fully assemble the model based on the provided drawing. You're given the standard orthographic views: front, top, and side. So make sure you're using all of them to understand the correct positioning of each component. Let's go over a few important hints to guide you. First, when you bring the pivot into the assembly, make sure to fix the pivot part at the assembly origin. This will act as your main reference and keep everything stable as you build the rest of the assembly. Add mates to make the probe sit as shown. The key requirement here is that the probe must sit horizontally, just like shown in the drawing. Also, keep in mind that the final assembly should have no interferences, so if something doesn't look right, it's worth running an interference detection check. Another important detail: the cylinder component is actually a subassembly, called the connector rod assembly. Make sure it is inserted as a subassembly and not as individual parts. Finally, after all the assembly, a mass assembly center must be found. This is a common requirement on the CSWP exams. So in this task, we're aiming to get the following center of mass results. X equals 251.6 millimeters. Y equals 800.3 millimeters. And Z equals 17.1 millimeters. Keep these values in mind. We'll use them later to verify that our assembly is correct. Alright, let's jump into SOLIDWORKS. First thing, always good practice, check your units. Make sure you're working in mmgs, millimeter, gram, second. If that's set correctly, we're good to move on. In the top right corner, you'll see a folder with all the parts, and just below that, the reference drawing. We'll be using those throughout the process. Let's start with the pivot part, the green one. Let's drag it to our assembly. Go to the Feature Manager tree on the left, right-click on the pivot, and select Float. This allows the part to move freely. Otherwise, it stays fixed in space and we won't be able to position it properly. Next, turn on the origin visibility so we can align everything precisely. Now, the pivot should sit roughly in this position, but the key point is to align its origin with the assembly origin. This step is critical because it defines the entire assembly structure. Here's how to do it step by step. Mate the bottom plane of the pivot to the top plane of the assembly. Then mate the pivot origin to the front plane. And finally, mate the pivot origin to the right plane. Once that's done, your pivot origin should perfectly match the assembly origin. Also, make sure the orientation matches the drawing. The front view in your model should correspond exactly to the front view in the drawing. Alright, moving on. Now let's bring in the con rod subassembly. According to the task, We are not allowed to insert individual components like the cylinder body or piston rods separately. We must use the complete subassembly. Alright, let's continue by adding mates and positioning the subassembly according to the drawing. First, I'll apply a width mate. Select the two side planes on the cylinder, and then the corresponding two planes on the pivot. This helps center the component perfectly between those faces. Click OK. Next, add a concentric mate between the cylinder, S-pin, and the hole in the pivot. Confirm it, and now the cylinder is properly installed. Now we need to connect the piston rod to the next component. But if you try to move it, you'll notice it's not moving at all. So what's going on here? This is a common situation with subassemblies. By default, they behave as rigid bodies. To fix that, go to the Feature Manager tree, right-click the subassembly, and select Make Subassembly Flexible. You'll notice the icon changes slightly. That means it's now flexible. And now we can freely move the piston rod as expected. Great, let's move on. Next, bring in the lower arm, the blue component. Place it into the assembly, and make sure the cutout is facing upward, just like in the drawing. Apply similar mates as before to position it correctly. Now for the probe. First, mate the probe to the lower arm, and then connect the piston rod to the lower arm as well. At this point, the mechanism should start looking very close to what we see in the drawing. We're almost there. Let's add the remaining components, the balance and the lever, and position them according to the drawing views. Alright, now all components are in place, and visually everything matches the drawing. Next, we need to fine-tune the orientation. First, make the probe horizontal. The easiest way to do this is by adding a parallel mate between the probe and a top plane or flat face. Then, set the cylinder angle to 10 degrees. Use an angle mate, select the appropriate faces or planes, and enter 10 degrees. Now let's validate the assembly. Interference. Go to Evaluate Interference Detection, click Calculate, and check the result. We get no interference, which is exactly what we want. Finally, let's check the center of mass. Go to Evaluate Mass Properties. In my case, I'm getting approximately x equals 251, y equals 806, z equals 17. So we're very close to the target values. The difference in the y direction is less than 1%, which usually means one of the mates might be slightly off or flipped. Take a moment to review your mates, especially angle and alignment conditions, and see if you can get even closer to the expected result. That said, the overall setup and workflow are correct, and this is exactly the kind of approach you need. If this video helped you, don't forget to like and leave a comment. I post new videos every week, so stay tuned.